Okay, attempt number 3. Screencast to help you analyze your data from the diprotic acid lab so that we can go more quickly with the spreadsheet on Tuesday, April 4th. So first of all, you either need to go to a campus computer lab that they all have Microlab installed on them, or if you would like, you can go to this website and download it onto your computer. It doesn't take up much RAM, it's really fast, so you can do that. Once you have Microlab on your computer, you can open the files that you emailed to yourself. Now, if by some chance you have some data points that are not okay, that you need to get rid of, the way that you do that is you first have to figure out where they are. So this one goes from about 31 to 0. Scroll down in the spreadsheet area of the Microlab file. So here, row 14, I'm going to select it by left-clicking, and then you need to right-click and disable this row of data. And you can do that for the rest of them. So here's another one in row 17, left-click to select it, right-click to disable, and then the last, wait, hold on, there's another one. I disabled the wrong row. Excellent. So I want to go back and enable that one. Disable this one. And then there's one more up here at around 10.8. So there's the 10.8. Left click to select, right click disable, all set. Now you can do your geometric and derivative equivalence points. So I'm going to go to my actual data. So this was for unknown J. And to get the geometric equivalence point, this is in your lab manual on page 111 through page 113. You did do this last semester as well. Most of you will have a titration curve with only one significant inflection point. If you have a curve that has 2 very clear inflection points, you can do the tangent lines for all of them, but I recommend just doing it for the most significant one, because your equivalence point 1 is just going to be half of your equivalence point 2. Or if you have your equivalence point 1, if you multiply it by 2, that will give you your equivalence point 2. So really just picking the most significant one is fine. And so we're going to do a tangent to the curve going this way, and this way. The way you do that is select domain, choose a nice set of points, and I'm at home right now at night with my boys and my dog, so if it gets loud, that's why. Analysis, add a curve fit is already selected. Okay, okay. We're going to call this line AB. First order, accept and save, zoom out. We're going to do the same thing up here. Select domain, analysis, add a curve fit is already chosen, so you just hit OK, OK. We're going to call this CD. Again, choose first order, accept and save, and zoom out. Beautiful. Now we just have to do the vertical one. And so I'm going to choose 3 points that are pretty in line with each other. And then analysis, OK, OK. Call this EF, first order, accept and save, zoom out. Now Microlab's trying to help you by using autoscale, but you can turn autoscale off. And now I'm going to move this window over. You see that there's 2 X's. So your actual equivalence point is somewhere in between these 2 volumes. So what I want you to do is in your notebook, let me scoot that over. You're going to write down geometric equivalence point for unknown, whatever unknown it is that you're doing. For me, this is unknown J. And you need to hover over the X to get your volume. Remember, volume is on the X-axis, so 39.55 is my first volume. And if I hover over this one, I get 41.97. And then you're going to add them together. and divide by 2 to figure out what your average is. So 40.76 mils. Now you have to ask yourself, is this my equivalence 0.1 or 2? If it's somewhere between 12 and 24, it's probably your equivalence 0.1. If it's above 24 mils, it's probably your equivalence 0.2. So I'm going to call this my VEQ2. So then what would my VEQ1 equal? It's just going to be 40.76 divided by 2. So 20.38. So those are the two volumes that we got using the geometric method for unknown, the first unknown, whichever one you're doing. Moving on. The next way to find the equivalence point is using the derivative plot. When I do that, I'm going to make this a little smaller here. What I like to do is hide these lines because they just kind of make it harder to see. So just select the line by left clicking and then right click, hide. So then you have a nice clean slate to work with. You're going to do an analysis again, except instead of a curve fit, this time you do plot a derivative. You get a nice derivative here because this is a pretty good inflection point. And in order to get a more accurate volume, I strongly suggest selecting and zooming in. And you find the point and you just kind of read down. So I would say this is at about 40.65. So in your notebook, you're going to put derivative equivalence point. And we found that it was 40.65. And so then that would be, again, your VEQ2. And so your VEQ1 will just be 40.65 divided by 2, which is, we'll call it 20.33. Great. So now you have the information that is going to help you get started on your spreadsheet. So let me bring up the spreadsheet. This template spreadsheet is on Moodle. And then if you notice, there's two tabs, first unknown, second unknown. So you can put your acid in the first tab. You should have all of this information in your notebook. So I hope that you fill in D5 through D9. And then we just figured out the VEQ1 and 2 using the geometric method. So those are right there. And we also did VEQ1 and 2 by the derivative method right here. And so as long as you can get that done before you come to lab, we will save a lot of time. Also, second unknown, this is your partner's information. So if you would please share with each other via email all of this information in these cells so that you can have both tabs started, that would be a big help. I think that's about it. If you have any questions, please don't hesitate to email me, and have a great weekend.